In this example, we start with a vector that has an x component of negative 1.2 meters and a y component of 3.4 meters. And the question is, what's the magnitude and direction of this vector? Well, the magnitude is easy. It just comes from the Pythagorean theorem. The magnitude is the square root of the x component squared plus the y component squared. So the magnitude is the square root of negative 1.2 meters squared plus 3.4 meters squared. Now realize to solve this properly, we have to square each individual magnitude and then add them. So we square 1.2, then we square 3.4, then we add them, then we take the square root. When we do that, we get 3.6 meters. Okay, getting the direction, or the angle, is a little more tricky. We start with the equation that the angle equals the inverse tangent of the y component divided by the x component. Well, we know the y component and we know the x component, so we can put those in the equation. So the angle is the inverse tangent of 3.4 meters over negative 1.2 meters. Notice that meters cancel, and when I work out the numbers, I get negative 2.833. Once again, I'm keeping all digits. I'll deal with significant figures at the end of the equation. Alright, when we take negative 2.833 and put it in the calculator and ask for the inverse tangent, we get negative 71. We rounded to two significant figures because both 3.4 and 1.2 had two significant figures. At this point, I suggest that you actually pause the explanation and go get your calculator and make sure you can get an angle of negative 71 degrees for the inverse tangent of negative 2.833. Calculators are very specific about how they want trigonometry entered, so you have to learn how your calculator expects trigonometry. Work with your calculator until you can get the proper angle from this equation. Once you've figured out how to get the angle of negative 71 degrees, we can concentrate on what this angle means. Remember, when we deal with vectors, we define the angle from the positive x direction. That's not necessarily what your calculator will give you, so we have to figure out the proper angle from this angle. To do that, we have to figure out what quadrant of the Cartesian coordinate plane the vector is in. So let's draw the Cartesian coordinate plane, an x-axis and a y-axis. Now let's look at the two components. The x component is negative. What does that mean? It means it's to the left of the origin in the Cartesian coordinate plane. The y component is positive. What's that mean? It means that it is above the origin in the Cartesian coordinate plane. So this vector is both to the left and above the origin. That's quadrant 2. According to what we have learned, when a vector is in quadrant 2, we have to take the angle that our calculator gave and add 180 degrees. So the proper angle is negative 71 degrees plus 180 degrees, which is 109 degrees. Look at the significant figures here. We're adding, so we have to go by the rule of addition and subtraction. In the rule of addition and subtraction, you don't count significant figures. You look at decimal place. Negative 71 goes to the ones place. 180 is exact, so it doesn't count when it comes to significant figures. So we can only report our answer to the ones place, and that's why the angle is 109 degrees. So, in the end, the magnitude of this vector is 3.6 meters. That's the length of the vector. And the angle is 109 degrees. That's the direction of the vector. You're going to be doing this kind of vector analysis for virtually the rest of the course, so you have to get very used to it. So we're going to go ahead and go through the next part of the example just to make sure you understand how to go from components to magnitude and direction. In the next part of the example, we're dealing with a velocity vector. The x component is 2.1 meters per second, and the y component is negative 4.2 meters per second. And once again, we have to figure out what are the magnitude and direction. Well, once again, magnitude is not so bad. The magnitude is the square root of the x component squared plus the y component squared. The x component is 2.1 meters per second. The y component is negative 4.2 meters per second. We square each of them, we add them, and then take the square root. When we do that, we get 4.7 meters per second. Remember, this is a velocity vector, so the unit should be meters per second. Now we have to look at the angle. The angle is the inverse tangent of the y component over the x component. When we take the y and the x components we were given and put them into the equation, notice that the units cancel. That's good because the argument of the inverse tangent function should not have any units. When we work out the numbers, we find that the angle is the inverse tangent of negative 2.00. Once again, we'll deal with significant figures at the end. So when we take the inverse tangent of negative 2.00, we get negative 63. I round to two significant figures because 4.2 and 2.1 each had two significant figures. Now once again, we have to figure out what this angle means. To do that, we have to figure out the quadrant of the Cartesian coordinate plane that this vector lies in. So once again, let's draw the Cartesian coordinate plane. Now let's look at the components of the vector. The x component is positive. That means it lies to the right of the origin. The y component is negative. That means it lies below the origin. So this vector is to the right and below the origin. That's the fourth quadrant of the Cartesian coordinate plane, and according to our rules, in that quadrant, we take the answer we got from the calculator and add 360 degrees. So the angle is really negative 63 degrees plus 360 degrees. Now once again, we're adding here, so we look at decimal place. We don't count significant figures. 63 goes to the ones place, 360 is exact, so my answer has to be reported to the ones place. So the angle is 297 degrees. So the magnitude of this vector, 4.7 meters per second. Its direction, 297 degrees.